Hi everyone, I'm super excited to be here and I'm honored to be part of State of OpenCon 24. I'm Alex, I'm a mobile app performance expert at BAM. We develop mobile apps in native, React Native, Flutter. We're based in Paris and London. And today I'm here to talk to you about mobile apps performance and specifically Android. So maybe show of hands, who here is first a developer? All right, so most people in the room. Who here is a mobile app developer or has already developed mobile apps? Okay, fewer people, so still some people, but maybe I'll add up the talk a little bit. No worries, it should be understandable for anyone. So I want to talk to you about performance because I came across this stat on the internet saying that 70% of users will abandon a mobile app if it is too slow, which in my opinion raises 2 points. The first one being that, well, obviously that means it's crucial to take into consideration performance when developing a mobile app. And the second one is, that's kind of a vague stat though, isn't it? Like, what does it actually mean too slow for an app? Like, how can we measure that scientifically? How do you even know if your app has good performance or not? So, this reminds me actually of a story of a client, and they came to us, contracting us to build a web app and also a mobile app. And what was good about this client is they had really good, strong technical standards. And on the subject of performance, on the web, their requirement was that all their pages should have a Lighthouse score over 90 out of 100. So if you don't know what Lighthouse is, it's a tool inside Google Chrome, and essentially you can go on any web page. For example, here I'm going on google.com, and easily, with just a few clicks, you can generate a performance report for your web page and get a score. Here, I thought that was a bit disappointing that google.com only had 80, but this client just told us, all of the web pages should have a Lighthouse score over 90, which was nice, good metric, easy to measure. And I was really curious what they were going to say for the mobile apps. And for the mobile apps, they basically just told us the app should not lag. That's it. So obviously, again, that was quite vague. And I started to think, okay, what's a good scientific measure of my app having good performance, my app not lagging? So I Googled it, and I came across a video from Google saying that Google's definition for a performant app is that it should run at 60 FPS, 60 frames per second. Because an app is basically like a movie, it's animated pictures. For example, if you're on Instagram and you scroll in your feed, your app is responsible for drawing the images going up, your feed basically going up 60 images per second at a time to give you a good impression of smoothness. I'm saying 60, but actually nowadays modern devices can go higher than that for, more smoothness. So that's a good definition, but the question is that enough? Well, obviously, if your app runs at 60 FPS, but it's actually burning down your phone in the process, probably your app does not have good performance. Sure, it will be fluid and everything, but it's probably better that if it utilizes as little resources as possible on your phone while doing so. All this to say that basically measuring mobile performance is a complex problem for several reasons. I'm going to explore some of them. The first one being that we do have several metrics to analyze and to take into account, like FPS, CPU, RAM, etc. Second reason is this. We had a client at some point doing a asking us for a performance audit on their app, and he was experiencing lags on his iPhone 13. But the app was cross-platform, so the same code running on iPhone 13 and on Android. Needless to say that the app was kind of barely usable on Android. So it really wasn't a performance audit as much as a, whoa, let's fix all the issues to make the app usable. Because this is the single core CPU score from Geekbench, scoring the performance of iPhone 13, which was the most sold iPhone in 2022. against the most sold Android phone in the world in 2022. Basically, the iPhone 13 can run your code 10 times as fast as the most sold Android device in the world. Which is crazy because, yeah, you basically need to take into account low-end devices when developing your apps. And I feel like sometimes as developers, we tend to have very good phones ourselves and maybe not pay attention to low-end Android devices. And actually, since 80% of CO2 emissions for a smartphone are due to its manufacturing, I think it's one of our responsibilities to make sure that users don't need to change phones every so often. So I think one of the things that we can do is, well, if we develop performant apps, then we make sure that it runs on older phones and users can be able to keep their phones for longer. All right, so again, measuring mobile performance, complex problem, also because obviously it varies greatly depending on the device, and you need to take that into account when doing your measures. Third reason, performance measures are just not deterministic. It's not like a test where you can go from red to green. Obviously, for example, if you measure your app startup time, at some point it's going to be 3.8 seconds. Maybe the next time it's going to be 3.9 seconds. Have you regressed by 0.1 seconds? Probably not. Probably it's just variability in the measures, right? So that's kind of annoying, and there's really no magic to this. Basically, the best thing you can do is run several iterations and average your measures or do a better statistical analysis. Ideally, keep the same conditions for every measure, like network, the data you're fetching and that you're loading, and as much as possible, automate the behavior you want to test to make it as easily reproducible as possible. But yeah, this is really time-consuming and annoying. So a third reason why measuring mobile performance can be a complex issue. Last thing I want to talk about in the reasons is, do not measure performance in debug mode. This left scars of me trying to fix some issues and realizing that the issue was only present in debug mode and not actually in production mode because of the framework that I was using. Frameworks usually work obviously better in release mode. In debug, they can add logs, etc. This is true for React Native, Flutter, for Jetpack Compose, and everything. I mean, every time you develop a mobile app, this is true in software in general. Do measure performance in profilable and production builds, because otherwise you might be fighting issues that your users will actually not be facing, or you need to fight what really has an actual impact for your users. Also, fun fact, your performance measures can be impacted by your performance measures themselves. This is a fun one, I think. For example, if you use Android Studio to profile memory usage in your app, it will actually increase the memory usage in your app. That's sink in. And luckily, it tells you that your memory usage will be higher, but basically the tool that you use to profile the performance of your app can also have an impact. And yeah, basically you need to be wary of measuring conditions to make sure that you draw the right conclusions when doing performance experiments. So just for simple reasons, I could have detailed a lot more, but just showing that measuring mobile performance is a complex problem. And yeah, if you think about what I was mentioning about the web in the beginning and Lighthouse, it was super easy. You go on Chrome, you open a web page, with a few clicks, you get a performance report out of the box, which I think is pretty awesome, and makes me feel like we need the same thing, but for mobile apps. We need a Lighthouse for mobile apps. So I'm really excited to show you that we've been working on a project called Flashlight. The joke being that I'm very proud of, but if you don't laugh, it's okay, that a flashlight is kind of like a pocket lighthouse, right? Like a mobile lighthouse. And so, yeah, the end goal is definitely to have a lighthouse for mobile apps. So let's have some fun with a little bit of demo. I have my phone here. Doop. Let me extend this window. like this. Maybe a bit bigger with the phone. I'm sharing my phone with something called Screen Copy, by the way, which is a open source package from Genymotion. Pretty awesome. Like this is, you can even click here and it will click on the phone, which I think is pretty great. So first I want to say, like, how did we actually build Flashlight? So I'm going to show that basically one of our first requirements was that it should work on any app with as minimal setup required as needed. Because Lighthouse, you can go on any web page. I'm not a Google developer. I can measure performance of Google. And we wanted to have the same thing with Flashlight. But the question is it even possible? And the good thing about Android is Android is based on Linux, so you get a lot of power actually out of the box. And you can communicate from your host machine with your phone with something called ADB, the Android Debug Bridge. For example, what I really enjoy is you can actually input text, for example. So I'm typing ADB shell input text, and it's doing it on my phone directly. But essentially, if you type ADB shell, you open a shell inside your phone. And for example, if I type uname, my laptop is Mac. Here I type uname, it's Linux. So it really is my phone. I'm really running a shell inside my phone. So I can do echo bonjour, and well, you don't really see it, but it's going to be running inside the phone and printing bonjour in the phone and just like showing it back, which I think is pretty awesome. You can do, of course, ls and a lot of stuff. So when you think about performance, well, the good news is on Unix systems, you get a lot of nice things, a lot of comments that you can use for performance. For example, here on my Mac, I can write top, and I can use top to display all the applications running currently and ordering them by CPU usage, for example. So here, of course, the Windows, the terminal, and screen copy that's actually running. So the question is, can we do this for Android? And the answer is, well, yes. I can just do ADB shell top to run top inside my phone. And here I get the same thing. So for example, here I'm on, I did not want to open this, but here I'm on Twitter, or maybe we say X nowadays, I still don't know. And for example, if I scroll, you will see actually Twitter at the top here of the processes and showing 118% CPU usage. It goes higher than 100 because I have 8 cores on my phone, so it can go up to 800. That's how it counts this. But so what I think is really awesome about this is, yeah, I mean, I could almost end my talk here, right? Like with this, I can measure the performance of, I get performance stats about any apps I want, and very easily, just ADB shell top, and that's it. So we actually took it a little bit further with Flashlight. But we took a look at the open source implementation of top in C++ inside the Android project. And we decided to develop Flashlight that builds on this. And OK, let me extend this window again. Oops, sorry, spoiler alert. And Flashlight is the easiest way to use it is via a web app. And you can just run Flashlight measure on the terminal. And here I can auto-detect the app that's running. And if I click Start Measuring, then same thing. It's basically a glorified ADB shell top, I would say, but a bit more complex than that. But essentially, you get FPS data out of the box. You get CPU usage out of the box, CPU per thread, and also RAM usage. So here, again, of Twitter, and I'm not a Twitter engineer, I did not install anything on the app or on my phone. I just had to run Flashlight measure. I do need to have the Android SDK installed on my Mac, but that's pretty much it, which I think is pretty awesome already. But we did not stop there. We went a bit beyond that, because I was saying that performance measures are not deterministic. So we created a command called flashlight test. For example, let's say I want to measure the startup performance of this cute Pokédex app. I can run flashlight test on my app ID, com.example, with a test command. Usually is end-to-end test, but here it's just an AB shell command to start the app. Let's keep it very simple to not make it last too long. I can tell it to measure performance for 5 seconds and to iterate twice. By default, it will do it 10 times. So what it's going to do is it's just going to repeat the comment that you passed it in test comment, like an end-to-end test, or here, just a comment to start the app. It's going to measure performance for the duration you asked it to, and it's going to do it a few times, 10 by default again. And at the end of it, you're going to get a JSON of measures that you can open with Flashlight Report. And so if I go to Firefox again, I can see that, yeah, I have my score 68 out of 100, kind of like Lighthouse. And I do get all the stats like CPU, etc., usage, and everything. So 68 out of 100 is not that great. Actually, yeah, we do have a performance issue in our app, so that's why it's not that great. Let's say that you fix your issue. You can just run, again, flashlight test command, generate another JSON of measures, and then you can compare them with flashlight report command, with flashlight report good and bad. And here you get the comparison view between the two of those. So here we see that, woo, we definitely fixed our issue. We have 71% less CPU usage. We get cool graphs, I think, between the two, able to, yeah, we can easily see that we definitely improved performance there. All right, so the question is, did we stop there? Lighthouse, the promise was that you go on any web page and with just a few clicks, you can get the performance score. Here, it can be a bit tedious. Still, you have to do the flashlight test, etc. You have to write your end-to-end tests. So we took it a step further, and we actually developed a cloud version, which is running basically flashlight test on AWS Device Farm. So I can just upload an APK. I can set up a custom end-to-end test, but I can also get my startup score as easily as typing here the first thing that some text that appears when my app is started. So for example, here Bulbasaur, which is the first Pokemon on the list. And yeah, maybe I'll just skip to the logs part, but essentially what it's going to do is it's going to look like this. It's going to run exactly like we saw the flashlight test command 10 times, starting the app, measuring performance and everything. And at the end of it, you're able to click the report here and see your score. So this is the bad version of the APK. So we get a score of 19. It's 19 is much lower than I got because my phone is actually a Pixel 8, which is by no means a low-end device, so I'm not even following my advice here. But here on the cloud, it's always using a Samsung A10s, which is a low-end device. And the good thing is you can still open a comparison view in the cloud. And for example, after you fix it, you can re-upload your APK and get the comparison view and see, again, that with improved performance. You can actually also the video actually follows with the graph, actually, I think it's pretty cool. And you can also play the video synchronously at the same time to just compare performance of good versus bad. All right, so let's come back to the slides. So we've shown this end-to-end performance testing, and that was taking it a step further, flashlight.dev. And, oops, sorry. We believe that at this point, we have a good candidate for being a lighthouse for mobile apps called Flashlight, with automated measures, supporting native Flutter React Native apps, production apps, and you can use it in CI with Flashlight Cloud. And the link is not there, but it's on github.com/bamlab, BAMLAB/flashlight. Also, it's, I want to point out that at this, we're starting to use it actually to measure performance for open source projects. So it's kind of fun to have an open source project measuring performance for open source projects, because we're currently tracking CPU usage across React Native version, and React Native is a open source mobile apps framework by Meta. And I want to thank all the contributors who made this possible, and specifically, I really want to thank people who mentioned that design is important, because this was the original version of the tool designed by yours truly, but I'm a developer, not a designer, and we came from this to this, which is, I think, a really neat improvement. So really thanks to those guys here. And yeah, that's it for me. Thank you very much for your attention. You can follow me on Twitter or whatever. I tweet mostly about mobile apps performance, and yeah, that's it.